Scientists just found a new object in our solar system. It's so far away and so hard to spot that it takes 25,000 years to circle the sun one time. This isn't a movie plot, it's real. The object is called 2017 OF201, and it's a Trans-Neptunian Object, or TNO for short. That just means it orbits way out past Neptune. Astronomers everywhere are buzzing about it. The discovery was announced on May 21, 2025, by the International Astronomical Union's Minor Planet Center. This icy object might even count as a dwarf planet. But the coolest part isn't just how big it is or how far away it sits. It's how this discovery is changing the way we think about the outer solar system and all the mysteries still hiding past Neptune. In this video, we'll dig into what makes 2017 OF201 so special, how it pokes holes in the Planet 9 idea, and what this could mean for the future of space exploration. 2017 OF201 follows one of the wildest paths ever seen. At its closest point to the Sun, called perihelion, it sits about 44.5 astronomical units away. That's close to Pluto's distance. But at its farthest point, called aphelion, it stretches out to a mind-blowing 1,600 astronomical units. That's more than 50 times the average distance between Earth and Pluto. With an orbit that takes about 25,000 years, this object spends almost all its time way out in the cold, dark edges of the solar system. Because of that, finding it was incredibly tough. We can only see this object from Earth about 1% of the time during its orbit. Even so, astronomers managed to spot it. They didn't even need a brand new telescope. Instead, they dug through old data already collected by the Canada-France-Hawaii telescope and the Dark Energy camera. That shows just how powerful our data tools have become and why it pays to look back at old observations with fresh eyes. As for size, this TNO measures about 700 kilometers across. That's roughly a third the size of Pluto, which puts it right in the range to be called a dwarf planet. Its round shape and likely mix of ice and rock make it a lot like other faraway objects the IAU has already labeled dwarf planets. Here's what really has scientists curious. How did such a huge object end up on such a strange path? Some think close encounters with Neptune or crashes with other big objects early in solar system history could have pushed it outward. Others think it may have formed closer to the Sun and got flung out into its current orbit while the giant planets were shifting positions long ago. There's also a theory that it came from the inner Oort cloud, a mostly unexplored area filled with ancient icy leftovers. Every one of these ideas gives us a peek into the solar system's messy past and hints at how it took shape over billions of years. One of the biggest debates in space science right now is whether Planet 9 exists. That's a theoretical giant planet orbiting far past Neptune. Scientists came up with this idea to explain why several extreme TNOs, like Sedna and 2012 VP113, have orbits that seem to line up in a strange way. That pattern suggests something huge and unseen might be tugging on them, maybe a planet 10 times heavier than Earth. But 2017 OF201 doesn't follow that pattern at all. Its orbit lines up very differently from the TNOs that support the Planet 9 idea. Scientists look at something called the longitude of perihelion, basically the direction each object points when it's closest to the Sun. If a massive hidden planet were really shepherding these objects, their orbits should cluster together. This TNO breaks that pattern completely. Its path looks scattered instead of grouped with the others. That raises a big question. Could the clustering we've seen so far just be a fluke caused by which objects we happen to spot first? This mismatch matters a lot. Simulations show that if Planet 9 were real, with the size and orbit scientists have guessed at, it should have knocked this TNO off course, maybe even flung it out of the solar system completely. That hasn't happened. So either Planet 9 isn't shaping things the way we thought, or the real picture out there is way more complicated than we assumed. But instead of killing the Planet 9 idea, this discovery shows we need way more data. Maybe TNO orbits aren't shaped by one giant planet at all. Maybe it's the combined pull of lots of smaller objects, or even outside forces like passing stars or the gravity of the whole galaxy. Either way, 2017 OF201 adds a new layer to a debate that's far from over. It's a reminder that science moves forward not only when we prove an idea right, but also when we challenge it. And that's exactly what this icy, distant object is doing. It's pushing astronomers to rethink how the outer solar system works, and just how much we still don't know. This one object might represent a much bigger, hidden group of worlds. Its discovery hints that there could be hundreds, maybe even thousands, of similar large TNOs on long, stretched-out orbits that we haven't found yet. Some might be dwarf planets. Others could follow even weirder paths. Every one of them could teach us something new about how our solar system was born and how it changed over time. A few objects already give us hints about this hidden group. Sedna, whose farthest point stretches almost 1,000 astronomical units out, was one of the first TNOs to show us this kind of distant, disconnected orbit. Then there's 2012 VP113, nicknamed Biden, another object that helped build the case for Planet 9. Like 2017 OF201, both Sedna and Biden travel on long, stretched-out orbits, hinting at some gravitational history involving more than just our 8 known planets. Closer in, we've got Pluto, now officially a dwarf planet, along with other Kuiper Belt neighbors like Eris, Haumea, and Makemake. These icy worlds are closer to us and better studied, but they belong to the same extended family. Each one teaches us something different about how planets and planet-like objects can form. Haumea spins incredibly fast, Eris is unusually dense, and Makemake has a surface rich in methane. Each one points to a different origin story, just like 2017 OF201 might reveal its own piece of this cosmic puzzle. Looking ahead, new discoveries could be right around the corner. The upcoming Vera C. Rubin Observatory is set to play a huge role in finding distant solar system objects. Its Legacy Survey of Space and Time, or LSST, is expected to massively boost the number of known TNOs and help us understand their sizes, orbits, and how they're spread out. And here's the most exciting part. Finding the next 2017 OF201 isn't just a job for professional astronomers. The data that led to this discovery was public. That means a student, a hobbyist, or an independent researcher with the right skills could make the next big find. This is the new face of astronomy, open, driven by data, and more of a team effort than ever before. As we keep digging through public data, sharpen our detection tools, and expand our sky surveys, the outer solar system will slowly come into focus. What once looked like an empty, frozen void might turn out to be a busy, mysterious region packed with objects that challenge everything we thought we knew about what counts as a planet. 2017 OF201 is proof that the far edges of our solar system are anything but quiet. They're full of motion, history, and hidden potential, and we've only just started paying attention. Thanks for watching. If you enjoyed this trip through the outer solar system, hit like, share this video, and subscribe for more amazing space content.